Welcome to Chemistry Basic videos. This is the second video of chemical equilibrium, and here we are going to discuss about Kc and Kp. Kc is equilibrium constant in terms of concentration, moles per liter, and Kp is equilibrium constant in terms of partial pressure. First we'll derive what is Kc, then what is Kp, and then we'll derive the relationship between the two. Now look here. Let us consider a gaseous chemical reaction AA plus B, B giving C plus D. The small a, small b, small c and small d are the number of moles of the reactant and the product. A, B, capital A and capital B are the reactants and capital C and capital D are the product. It is reversible, so you will have to put that double arrow. Now applying the law of mass action to the forward reaction, we'll get RF, rate of the forward reaction, is directly proportional to the concentration of the reactant A raised to number of moles of A into concentration of B raised to number of moles of B. Therefore, Rf is equal to Kf, the constant, A raised to small a, B raised to small b, where Kf is the rate constant we have discussed in the first video. Rf is the rate of the reaction. Now let us apply same thing to the backward reaction, law of mass action to the backward reaction. The rate of backward reaction is directly proportional to the concentration of the product C raised to number of moles of C and concentration of D, reactant product D, raised to number of moles of D. So RB will be equal to Kb to concentration of C raised to C, concentration of D raised to D. We know that at equilibrium, Rf is equal to Rb. Therefore, Kf into A raised to A into concentration of B raised to small b is equal to Kb into concentration of C raised to C into concentration of D raised to D. Therefore, Kc is equal to equilibrium constant in terms of concentration is equal to Kf upon Kb, which we know from previously, into concentration of C raised to C into concentration of D raised to D, A raised to A and B raised to B. This is equilibrium constant Kc in terms of concentration we have done earlier with a very simple reaction A, B giving C and D. Now this is Kc. Now we have to go for what is Kp. Kp is what? Equilibrium constant in terms of partial pressure. So now we are going to do what is Kp, calculate what is Kp. Apply the law of mass action to the forward reaction. Rf is directly proportional to Kf, and partial pressure of Pc, that is partial pressure of A raised to A into partial pressure of B raised to B. So Rf is equal to Kf into partial pressure of A raised to A, partial pressure of B raised to B. Same way, if we apply the law of mass action to the backward reaction, we will get Rb is directly proportional to Kb into partial pressure of C raised to C into partial pressure of D raised to D, or R B will be equal to Kb into partial pressure of C raised to C, partial pressure of D raised to D upon, that's all. At equilibrium, Rf is equal to Rp. Therefore, we'll have Kf into partial pressure of A raised to A into partial pressure of B raised to B is equal to Kb into partial pressure of C raised to C into partial pressure of D raised to D. Pause karo, haan. Therefore, Kp is equal to Kf upon Kb, which is equal to partial pressure of C raised to C to partial pressure of D raised to D upon partial pressure of A raised to A into partial pressure of B raised to B. This is Kp. Now we will be substituting the partial pressures of A, C, D, A and B. How to substitute that? That is the extra point over here. We know ideal gas equation, PV is equal to nRT. Pressure into volume is equal to number of moles into gas constant into temperature. So P is equal to N upon V into RT. What is N upon V? Moles per liter. So P is equal to C into RT. C is concentration. C is concentration. Therefore, partial pressure of the gas A is equal to concentration of the gas A into RT. Partial pressure of B gas is equal to concentration of B into RT. And partial pressure of C is equal to concentration of C into RT. And partial pressure of D is equal to concentration of the gas D into RT. So, we will be substituting this in this equation Kp. So, on substitution we get Kp is equal to Pc. What is Pc? Concentration of C into RT whole raised to small c. Then, what is partial pressure of D? Here it is there. Concentration of D, which should be in the bracket, into RT raised to small d, divided by partial pressure of A. What is that? Concentration of the gas A into RT, the whole raised to small a. And then partial pressure of the gas B is here, concentration of B into RT, the whole raised to small b. So this will become concentration of C raised to C into concentration of D raised to D, concentration of A raised to A, and concentration of B raised to B. See here, therefore Kp will be equal to concentration of C raised to C into concentration of D raised to D upon concentration of A raised to small a into concentration of B raised to small b into RT. C plus D minus A plus B, C plus D minus A plus B. Now, just now we have derived this part is Kc, equilibrium constant in terms of concentration. So we get Kp is equal to Kc into RT raised to C plus D minus A plus B delta N. This is the relationship between Kp and Kc. Remember, what is delta N? It is the number of moles of gaseous product minus number of moles of gaseous reactant. This one should not make mistake upon reactant. They should not say it is reactant minus product. Number of moles of the gaseous product minus number of moles of the gaseous reactant. Now, last point. If somebody wants to write what is Kc, He'll write Kc is equal to Kp into RT raised to 1 RT raised to minus delta n. It will become 1 upon RT raised to delta as well as minus delta n. So both way Kp and Kc is over. Okay. If in a reaction there is no change of number of moles, gaseous reaction, if there is no change of number of moles means C plus D is equal to A plus B, then we'll have C plus D minus A plus B is equal to 0. In that case, this part will become raised to 0. This will become 1. Therefore, Kp will become equal to Kc. So, in those gaseous reaction where number of moles of gaseous reactant is equal to number of moles of the gaseous product, delta N becomes 0 and then Kp is equal to Kc.